We bought this F-body Firebird roller for $1,000, and since then, it's been our project drag car. Now, we ain't made of money around here, so we do everything ourselves. That way we can spend the cash on the parts that matter. I'm Josh, and I like whiskey, and I like going fast. And you're watching High Noon Racing on YouTube. Welcome back to the garage. Today, we are diving deep into... I really wanted to start off this video by saying, how does 3D printing with car parts and like brackets and stuff like that benefit me? And how it benefits me is I don't have the income to constantly buy $500, $1,000, $2,000 parts for my build, so my build takes longer. So while I'm saving money and whatnot, I can knock out some really cool detailed parts in 3D prints that add a lot to my build, make it look really clean, really nice. Like you could do cable management stuff where, you know, the hoses are nicely clamped down into a 3D printed bracket. The sky is the limit with 3D printing. If you can imagine it, you can 3D print it. I'm gonna try and go over everything that you should know up front in this video. So like what you're getting into and the cost. Now, something super important is I'm going to leave a ton of links in the description below and more information in the description below. In the video, I'm not really going to go over too much of like what printer to buy and the price range, but I will in the description. So after you're done watching the video, if this is something you're still interested in, make sure to check out the description because I'm going to leave links to different types of filament, different types of printers, the softwares I use, just in case some of you are intermediate in this field, like with designing stuff and whatnot, but you're not sure about 3D printing. This will actually benefit you as well. But this video is pretty much going to be based for the person that has no clue if this is what they even want to get into, and you should have a good idea if this is for you or not at the end of the video. The world of 3D printing, where creativity knows no bounds, and innovation is at your haunts. Welcome back to the garage, where today we're diving deep into 3D printing practical parts for your cars. Well, mostly like race car stuff, but we'll get there. Have you ever wondered, is 3D printing expensive? Is it easy to learn? What does it cost to get started? And most importantly, how can 3D printing benefit you? In this video, we'll dive deep into these questions and unravel the secrets of 3D printing, affordability, simplicity, and its unlimited potential. So buckle up as we embark on a journey to explore the fascinating world of Stella's hole. Oh, you can't show that on YouTube. You cannot be showing that on YouTube, Missy. Unreal. Fascinating world of 3D printing. Now, this is a pretty vast topic to cover. And today, this might be an intro to a new series that we put here and there. And we'll make a new playlist about this. But if this is something y'all are interested in, I'm talking to you. It's something you want to learn how to do. Like right here, it's a little switch panel. This goes in my dash. And the switches get mounted to this. It holds them in place. Looks kind of cool, you know? Get a little multicolor action there. Surface finish looks decent. This right here is a custom dash that I made to hold in the Holley 3.5-inch screen. This little slot right here that's kind of ugly, I actually made so that you can push the SD card in and take it out right there without having to go behind it. There's a nice little hole in the bottom for the cord for the 3.5-inch dash to actually, you know, be routed behind it. So cleans things up, looks cool. It's the color I want it. This is the type of stuff you're interested in. I can show you how to do it, but you gotta let me know this is what you want to learn. Like if y'all are interested in this, and it gets enough attention, I'll put some time into showing you guys how I do this. So another thing real quick, I'm gonna grab a camera. Y'all simmer down. I know I'm gonna manhandle y'all. Get you some turkey, just simmer down. All right, so this right here is another just cool thing that you can do. I mean, this is something I did. This is our logo here at High Noon Racing, and I just did 3 parts of it, and I printed it. And the surface finish isn't that great, but it's pretty damn good if you knew what all the parameters were, like what all is actually going on. But the cool thing is the other side is beautiful. Kind of like how this one is and how this one is. Now don't you look at that. I know y'all seen it. I know as I was panning, y'all seen it, so I'm gonna call it out right now. So that lifted off, that's a little part that was on the bed that lifted off, and I just stuck it on there, and the 3D printer went over it, and I was hoping for the best, but it looks like it knocked it out of place. But that doesn't always happen. That's gonna bring me back to, there's a lot of topics in 3D printing, designing, measuring. Don't be scared of it. Definitely don't. There's some budget options out there for sure. But number one in 3D printing is, this is something you want to get into and you have no clue about. If so, 2 parts. This is something you want to get into and you don't have a clue about any of this stuff, like where to even start. If those are 2 things that are true, then you 100% are going to need one thing, lots of time. It's going to take some time. I can show you all the shortcuts and I'll teach you how I do things, make it nice and easy, and you'll be able to do it no problem, but it's still going to take time. All right, so let's just start with the measuring tools. 2 tools that you're going to need, pretty much the only tools you'll need for 3D printing and parts and stuff. Tape measure, that's for measuring anything. Well, most of you probably won't need this. Tape measure, so you can measure, this is 12 by 12. The way I have it spaced out right now. But you gotta be able to measure things so when you're designing them, you know what to put them at. I think I actually made this 15 by 15. Which brings me to my next point. 15 by 15 is pretty big. There's not a lot of 3D printers out there that can accommodate a 15-inch by 15-inch 3D print. So this is also gonna somewhat complicate things. Does it increase the cost? Not really, no. You could still get a good printer for something that can do 15 by 15, like this in one shot. You gotta have a big printer. But there's ways. You could print this a little thicker and do a little like puzzle piece in between the 2, glue them together, and that's the one in my car right now is like that because I didn't have a 3D printer at the time big enough. There's so many ways to do so many different things, but if this is something you want to get into, you got to show me interest, because I'll go down that rabbit trail with y'all. I'll show y'all where to hunt. Y'all got to let me know you're willing to hunt, because if you ain't willing to hunt, you ain't gonna get nothing. All right, so we talked about the one tool, tape measure. Everybody's pretty much got one of those. These are calipers. If you've never used them before, don't be intimidated. They're not hard to use. You just fire it up by hitting the on button. You got millimeters and you got inches, which is showing down there in the bottom left. If you don't know how the decimal points work, let's take a little gander real quick. So you got your 0, and then getting a little carried away here. So right now these are closed, but it's reading something. So we'll click 0 and it just kind of resets it. Now we're back at 0. Now we're good to measure. So this little thumb dial here, you're gonna crank, and I'm gonna try to, okay, so 0.5 inch is, you guys should know, 0.5 inch is half an inch. So if something measures 0.502, that's half an inch and 2/1000ths of an inch. So that's how that works. You ain't gonna need to go that far. So with 3D printing, everything you're going to 3D print, 3D printers' tolerances are usually 5 to 10 thousandths off, meaning you need to, so if something measures half an inch, we'll say right there, 504. So half an inch and 4/1000ths of an inch. You would need to design it at, oh, this is going to be really hard, 505. Oh my God, I nailed it. 505 to 510 to make something physical actually fit in a hole. So if you designed a circular hole in something like this, you need it 5 to 10 thousandths of an inch bigger so that something will actually fit. And the reason why is because 3D printers are accurate, but not that accurate, and the filament kind of lays out. That's just something to keep in mind. You can't do perfect designs with perfect measurements that are 100% accurate and 3D print it and get what you want, offer it. You can work your way to actually getting there if you want. If you have that kind of time, you can, but 5 to 10 thousandths is just kind of like a general rule of thumb. to increase if something's going inside something and it needs clearance, like some sort of gap has to fit. It can't be like 100% accurate. 5 to 10 thousandths, sometimes a little more. You want to give it in clearance test. So you're going to add that to everything that you're designing. So now back to the tools so far. We have calipers, which I think you can get on Amazon for like 20 bucks or something like that. And tape measure, which pretty much everybody has or knows where to get. Those are the two main tools you need for 3D printing. A notebook and a pen, just so you can measure things and write down and draw it out. I'm going to show you guys how I design stuff, and I guess I will take you through the design kind of process just to show you how quick and easy it can be. I'll show you the time that it currently is and the time that it is after, and we'll design something together just to kind of give you an idea, and then we'll print it. The next topic I'm going to talk about is 3D printers and print quality. So can you buy a 3D printer and just straight off rip start laying down some Mac Daddy clean lines? No. Is there any 3D printer you can buy? Sure, if you got like 20 or 30 grand to spend, yeah. All of them need to be dialed in, and there's ways to dial it in, and certain things that affect that. So print time for 3D prints can be an hour, and then if you change the nozzle to a smaller nozzle to get higher quality prints, it can go up to literally like 6 hours. So for example, this is a smaller nozzle, which is higher quality looking, right? Much less to notice there compared to these lines that are very noticeable. That was a 27-hour print that I aborted, like half a spool of filament. And yeah, that didn't come to fruition because it wasn't gonna fit to begin with. It's going to be a cup holder with a phone spot for a phone. Guess what? Doesn't fit the phone. This is another print. Went to a way bigger nozzle, which means you can print way faster, way more material through it. So this is like I think a 1-day print. And I wanted to experiment with this surface pattern to see how it turned out. And what happened was the sides of this on the print bed, you may not be able to tell on camera, but they're slightly lifted up. So what happens is, since this lifts up, it hits the nozzle and creates this while you're at work. 23 hours wasted. That's okay, because the fix for that was literally increasing the temperature of the build plate just by like 5 to 10 degrees Celsius. There's a lot to do in this 3D printing realm. If you have the time, it's not that bad. So let's get to another example. For prototyping, like you got a design idea, you want to make sure it fits. You could save a ton of time by printing something super thin. That way it prints fast, doesn't use a lot of material, and you could have even saved more time by putting holes in your design so it only prints just the outer area. It saves you a lot of time, a lot of material, and then you can go and put it in there, make sure your measurements worked, make any changes you need to make, and go to the next print. So here's one. Went to the thicker nozzle, was still dialing in the machine. As you can see the gaps, you see the layer that's going the other way underneath these lines. I was still dialing in the machine here, and at the same time I wanted to test out this surface finish, which is like a big circle. Looks kind of cool, but the machine needed dialed in, so this will work. This is the right size. And then it hit me. Oh yeah, by the way, another problem. Should have mentioned this, didn't realize it. This print is in a filament called PETG, which is basically what, if you're here on my channel, you're probably going to be using. It's heat resistant to a point where your car can sit in the hot sun and this is not going to warp. It's strong. It can flex pretty good without breaking. This is a good filament, it's cheap, and it works. And if you dial it in, it'll get good results. But PETG will stick really well to a glass build plate. Now, a lot of printers, especially in our price range, are going to come with a glass build plate. Now, the one you've seen in these past video clips, that is not a glass build plate. That is a PEI build plate with a special surface, and it's kind of cool. When that build plate cools off, the print literally just like pops off of it. It's super simple. If it doesn't, you can flex it. You pop it off because it's magnetic. You flex it and the part comes off. This right here is with a glass bed. Did not do that. In fact, it actually lifted, whether you want to believe it or not, that is glass right here, it lifted a layer of glass off of the bed because it's stuck so good. But anyways, this is more experimenting. This was prototyping. This is more prototyping, super thin. Prototyping again, thin, but a little bit more rigid. And let's see, I was saying, hey, go from 0.35 thousand holes to 0.40. This is part of calibrating the 3D printer. When I change the nozzle, there's these tests you can run. This is a test you can run to dial it in, test you can run, tests you can run. So like I said, it takes time. One of the main reasons why it takes time is because you have to run a test, which takes time to print, and then make a change. It's super easy to calculate. Now that I've figured it out with the newest and latest and greatest, I can save you guys a ton of time not doing this. You maybe run 2 or 3 tests and then you'll be back to gravy. But yeah, time takes time. Now, good thing about this hobby is it is super cheap, super rewarding, and just all around really good knowledge to possess. So it's definitely good. Let's take another look. I'm gonna give you an example of one of the tests that you'll have to run. So this is it's like an accuracy cube, I wanna call it basically. So when you print this with your printer, we're gonna turn this into millimeters. This is supposed to come out to 20 millimeters exactly on the measurements all the way around. That's pretty close, but that's not perfect. Well, that's pretty close, but that's not perfect. So as you're making these, remember, I stepped up to a bigger nozzle so I can start printing faster. Print quality's caca, but we want accuracy and then we work on print quality. So this one's a little bit better. And then boom, this one's way better. Has a few defects, but way more cleaner looking with the bigger nozzle for faster prints. So let's give this a measure real quick. Look at that accuracy. It almost does not get better than results like that, but you have to be willing to put in the time to get results like that. You don't have to get that accurate, but y'all are gonna learn. Your boy here likes to be accurate. All right, so after we did that, now we know our stuff's gonna be pretty good. It's actually one of the last tests you're gonna kind of perform to dial in. The first test, some of the first tests, I don't have the order in my head right now, but I'll make it up and make sure it's right for y'all. But another test you're gonna do is called a flow test, where you see how that may or may not see. I'm trying, guys. So it says -1 on top. It's kind of hard to see with these bigger nozzles, but that's -1 on the flow rate, and the surface finish looks like that with our bigger nozzle. It doesn't look horrible, but -2 kind of looks better. This is 0. Looks good, but it doesn't look great. There we go. Here's -8. We didn't even have to finish that test. But you guys kind of get an idea of how these tests are working. So this is a flow rate test. How much should I flow through this nozzle with my machine? So it's no changes. That's what we got. -1, that's what we got. -2, that's what we got. -8, that's what we got. And it does all of these at one time. So like here's -7. Here's -6. And basically, you throw it through the gauntlet. It's one print. It probably with a 0.8 nozzle like I'm using, because I like prototyping, doing stuff quick, and then dialing it in, fine tuning, so that I can get fast prints. Because 23 hours, not my deal. With the new nozzle and this changed up, especially design wise, probably print that in like 8 hours. So you go to work, you come home, and it's done. That's ideal. My point being, there's gonna be, you buy a 3D printer, you're gonna have to do this stuff. Now, I can walk you guys through this because I just went through the gauntlet with a new printer, so it's fresh in my mind with the latest and greatest techniques. But keep in mind, I say it again, it's gonna take you time. Now, designing is not hard. The hardest part is kind of learning to navigate the software and understanding like certain things. Now, if you're not in manufacturing and you haven't been in manufacturing, you don't work with technical drawings, this stuff is going to be just that much harder to grasp with the design aspect. Now, it's still really not that far out of reach, especially for people like us, hands-on people. This will come almost naturally to you once you start picking up how it works. You'll get faster and faster and faster as you do it. Like a couple years ago, making my own design for something might have taken me all day. Now I'm pretty much knocking them out and getting a lot of detail in them the way I want them in a couple hours. And it doesn't even have to be like that. It's just when I like detail. Something like this, yeah, that was multiple days because you take all the measurements, you do your prototyping, and then you do some experimenting, and yeah, that definitely took a couple days. Something like this though, start to finish, 5 minutes, not including printing time. Design time, literally less than 5 minutes. Those are tricks that I'll be able to show you. I'll show you the softwares I use and stuff like that. This is going to be kind of a long video of me talk, but I'm going to try to cram in it as much hands-on as possible. And if you guys don't let me know this is what you want to see from me, it will die here, right here. But on the other hand, you guys tell me this is what you want. We'll cheers it up, babies. I'll show y'all the sweet ways.